The three states of matter are surrounding me, as solid, liquid, and gas you see. Water can be all three. Hey, ice, water, air. Water can be all three. Hey guys, welcome back to your 8.1 section video. This is I'm talking about the three states of matter. Here's your bell ringer right here. Go ahead and read it up, and you know what to do. Post it up there on edmodo.com. All right, here we go. Here's our objectives for today. Today we're going to describe the properties shared by particles of all matter. We're going to describe the three states of matter, and we're going to explain the difference between each of these states of matter. That is what we'll be talking about today, ladies and gentlemen. So here we go. Particles of matter. When we talk about state of matter, what we're talking about is the physical form in which that substance exists. In other words, is it a solid? All right. Is it a liquid? All right. So a solid like this. Is it a liquid like what's inside of here? Or is it a gas like what's coming out of my mouth? Carbon dioxide. Is it a gas? When we talk about particles of matter, we talk about those three states of matter. Now, just so you know, there are really about 5 states of matter. But for our purposes right here in 8th grade and really through high school, you only need to know about the 3 states of matter. The other 2 states of matter are going to be plasma and the Bose-Einstein condensate. When we talk about plasma, it's a collection of free-moving electrons and ions, and the Bose-Einstein condensate are atoms that are melted together to form the shape of an atom. All right, and they are at absolute zero. That's how cold that Bose-Einstein condensate is. But you don't need to know that. Just in case you were wondering, there are really 5 states of matter, but the 3 that we're going to really worry about are solid, liquid, and gas. All right. So matter, what is matter? Matter is made up of very, 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 very tiny particles. We call those tiny particles atoms. And the atoms are also formed into molecules. All right, so the smallest form of any particle is an atom, but the smallest form of any chemically combined particles is a molecule. All right, so we have those 2 different types of particles that make up all matter. All of those matter. Now, the thing to remember is that all matter, regardless of whether it's this phone, whether it's the liquid inside of here, whether it's the gas coming out of my mouth, all matter is always in motion. All matter is always in motion and always bumping into each other. Now, you probably are thinking, how is that possible? All right, but it is possible, and we'll talk about that in just a second. Now, they interact with each other. All these particles in the matter, all the atoms inside this matter interact with each other in a very specific way that helps us determine the state that it's in. The way that they do, well, I just told you that. And the interactions in the 3 states of matter are shown here the next. Now, you're thinking about this phone. You're thinking about your desk. You're thinking about the computer that you're watching this on. You're thinking about, the building that you're in, and you're saying, wait a second, Mr. Lewis, there's no way that a solid is actually moving. If I were to set this down, I were to hold this, there's no way that this is moving. But in reality, the particles that make up this phone, the particles that make up the desk, the particles that make up this computer, those particles, those atoms are vibrating in place, all right? But they're not vibrating fast enough. They're not moving fast enough where they can overcome the attraction to each other. They are attracted to each other, and they can't break away from each other. So they are, in that first picture over here, they are lined up in an order, vibrating fast enough, but they're vibrating together, but they're not vibrating fast enough that they can overcome the attraction of those together, of those particles together. The second picture talks about a liquid. Now, the particles in a liquid, of course, are solid, are atoms or molecules, depending on what you're looking at. The particles of a liquid are vibrating fast enough. They're vibrating faster than a solid that they can actually slide past each other. And since they're able to slide past each other, they are able to move, all right? And they are able to take up the shape of the container that they're in, because those particles are moving fast enough that they can slide around and they can take the shape of the container that they're in. Now, when we talk about the particles of gas, those particles are moving so fast that they can't stay together. They're just bouncing all over the place, and they're just going willy-nilly everywhere, because that's what gases do. So you have the solid, they're locked in place, they're vibrating, but they can't get past each other. You have the liquid that slide past, they're moving fast enough that they can slide past each other, and you have the gases that are just like all over the place, okay? Now, let's talk about solids first. Now, when we talk about solids, we're talking about something a substance that has a definite shape and a definite volume. So in other words, this right here has a definite shape. This right here has a definite shape. All right, it has a definite shape and a definite volume. You can easily calculate, this is easier than trying to do it with this. This is easier to find our volume of this. All we have to do is measure the base times the height times the width, and we can find the volume of this. It has a definite shape. When you hold this in your hand, it doesn't start melting and drooping everywhere. It stays in the definite shape, and it keeps the definite volume. Now, they do not move, the particles don't move fast enough to overcome their attraction, but they do move. And there are two types of solids that we have, okay? There are the crystalline solids, and then there's the amorphous solids. Now let's talk about the crystalline first. The crystalline first are lined up in a very orderly three-dimensional pattern. All right, so things like a diamond, like ice, like iron, those are crystalline solids. They are lined up, the particles in them are lined up in a very definite shape, in very three-dimensional arrangement. They're lined up together. Then you have the amorphous solids, which it doesn't make any kind of sense as to how those particles are lined up. And so they don't have a special arrangement. Things like glass, like rubber, like wax, those are amorphous solids. Those things, when they join up, they're just joined up any kind of way, willy-nilly and stuff like that, okay? Now, when we talk about liquids, liquid is a state of matter that has a definite volume, all right, has a definite volume, but it takes the shape of the container that it's in. So if that liquid is inside of this container, okay, it's going to take the shape of this container. I could fill this up to here with water, and guess what? When I fill this up to here with water, it's going to be that much water. Now, if I were to take this and I were to pour it into this one, now it's going to look like there's less water in here because this is a bigger in diameter beaker. However, it's the same amount of water in here as there is in here. It's just now it's taken the shape of this container. So that's what they mean by it has a definite volume. It'd be the same amount of water that is inside of here as I put inside of here. It's the same amount of water, but it takes the shape of the container that it's in, okay? And obviously, it's the reason for that is because those particles can move fast enough that they overcome the attraction, they slide past one another. All right. They do have unique characteristics, and those characteristics are called surface tension and viscosity. Now, let's take a look at surface tension first. All right. Surface tension is a force that acts on particles at the surface of that liquid. So in other words, at the very top of that liquid, there is something that happens at the surface of that liquid. There is a force that acts on it. Now, if the liquid has a low surface tension, all right, when it forms, if you were to take a drop of it and drop it on the ground or on a solid piece of solid piece of something, it'll form a very flat bead. Okay, so for an example, if you were to take gasoline and you were to drop gasoline, put a drop of gasoline on, let's say, a piece of glass, the bead on that is going to be very, very shallow. All right, it's going to be very flat. But if you were to take that same dropper and take a drop of orange juice and drop it onto that same piece of glass, it's going to form more of a rounded bead. And that's because orange juice has a high surface tension. So if it has a low surface tension, it's going to form a flat bead. If it has a high surface tension, it's going to form more of a rounded bead. All right, when it lands on that piece of glass. Bead is the drop of water on that piece of glass. Then we have viscosity. And viscosity is the resistance of that liquid to flow. Okay, so if the substance has high viscosity, it's going to flow slower. So if you were to take honey or syrup and you were to try and pour it, you'll notice that it goes very, very, very slowly until eventually it pours out. But it's still going to pour very slowly. If it has a very low viscosity, you're going to take it and you're going to pour it. It's going to come right out very quickly, just like water. So when you pour water, if you were to take a cup of water and a cup of honey and you were to pour them at the same time, which one's going to empty the container faster? The water will empty the container faster because it has a lower viscosity. It's going to flow faster. That honey is going to have a high viscosity. It's going to flow very slow. Those are two unique characteristic special properties of a liquid. Now, when we talk about gases, gases have no definite shape and they have no definite volume. Okay, the gas that we have, or gas that's out there, has no definite shape or no definite volume. Now, gas will take the form of the container it's in. So if you blow up a balloon, the gas is inside that balloon. It's taking the form of that. But if you let that gas out, it's just going to go willy-nilly everywhere. There's no definite shape of it, and there's no definite volume of a gas. All right, and those particles are moving so fast together that when they come together, or when they're held together, they'll start bouncing and going everywhere, all willy-nilly. And that's simply because they are moving so fast, the particles are moving so fast, that they can break away completely from each other. All right, and there's a large amount of empty space between each of those gas particles, and that empty space can actually change depending on temperature and pressure and those kinds of things as well. So here's your Chapter 1 8.1 review. Now, guys, I'm going to tell you, Chapter 9 and above, you are not going to have this review section here. All right, you're going to have to start taking your own notes. So you need to go back in and look at how I'm taking these notes for the review section and put it in your notes as well, so you understand how these are being done. If you have any questions, you can always see me in class, and I'll help you take these. I'll help you do that section review. Okay. Well, you guys, I'm going to be quiet so you guys can go ahead and do this. Okay, well, I hope you guys enjoyed that video. This is your 8.1 video. It's me, Mr. Lewis, signing off, and I'll be seeing you in the future.